there was a meteor detected by US government satellites moving faster than 95% of the stars. The chemical composition was different than materials from the solar system. I decided to lead an expedition to search for the materials at the bottom of the ocean, and we can tell the difference between a rock and a technological gadget. If we find a gadget at the bottom of the ocean and it has, for example, buttons on it, should we press a button? So altogether, within a year, my hope is we will find many more objects like Umuamua. But even before Umuamua, 4 years earlier, there was a meteor, an object the size of a watermelon, half a meter or so, or bigger, that collided with Earth and burned up in the lower atmosphere. And it was detected by US government satellites that are monitoring the Earth for ballistic missiles. Every now and then they notice a collision between an object from space with Earth because they see the fireball. This collision released a few percent of the Hiroshima atomic bomb energy. And once the Department of Defense realized that it's an astronomical object, not related to any warfare here on Earth, they released the data in a catalog that NASA put out. And together with my student, Amir Siraj, we realized that this object was unbound to the sun, that it came from outside the solar system. So it was actually the first interstellar object before Oumuamua, almost 4 years, discovered on January 8th, 2014. And it also looked weird because it was moving faster than 95% of the stars near the sun. And also it exhibited material strength that is tougher than iron meteorites. So it was tougher than iron. It only disintegrated when it reached the very dense lower atmosphere of the Earth. It exploded about 20 kilometers over the Pacific Ocean. And the US Space Command confirmed that this object was indeed interstellar, that it was moving too fast to be bound to the sun. And I reached out to them because my colleagues were saying, we don't believe the US government. And I reached as chair of the board on physics and astronomy, I reached through the White House, and the US Space Command issued a letter submitted to NASA to confirm that this is indeed an interstellar meteor, the first recognized interstellar meteor. And there was another object that was discovered in 2019 from interstellar space that happened to be a comet, a regular comet, the way we see comets in the solar system. They're basically a rock covered with water ice that gets evaporated when it comes close to the sun. And people ask me, okay, well, this one, which is named Borisov, this comet is familiar. It's natural. We know about comets. So doesn't it convince you, they ask me, that Oumuamua was also natural and not artificial, not technological? And I said, well, if you go down the street and you see a weird person, and after that you see a normal person, it doesn't make the weird person normal. So Oumuamua was still quite unusual. Mm-hmm. And so this entire field of study of looking for objects that came into the solar system from outside and figuring out whether among the rocks that look familiar, there might be some space trash from extraterrestrials. That was never pursued before. And that is my current focus. I'm trying to figure out if any of these objects might have been technological in origin.
Very, very interesting. And when it comes to, I mean, you said that the universe is 13.8 billion years. Humans have been around for how long?
A few million years. Just one part in 10,000 or so.
So, kind of what I'm getting at is, I had this conversation, it may have been Tim Gallaudet, but whoever it was, we were talking about what are the chances that humanity as we know it lines up on the same timeline as other extraterrestrial life. Maybe we are the only ones in the universe
Right now.
at this time.
Yes.
And I've been thinking about that ever since we had that conversation. But now, when you're telling me that we can see back to the beginning of the universe, it sounds like there's nothing that we couldn't collect
Right.
over the 13.8 billion years with the technology that we have.
And also that the Milky Way is like a wastebasket that collected all the space trash over the billions of years that elapsed since the first stars formed. And, we can look into this wastebasket and check if someone existed before us. They don't need to live right now with us. And so it's a completely different approach to searching for others that may have existed billions of years ago, left behind some monuments, some space trash that we can find.
Wow.
And now the key question is whether any of the objects that comes close to Earth is still functional. Because our own Voyager, for example, will not be functional once it leaves the solar system to interstellar space. When it exits from the Oort cloud, the outer boundary of the solar system, it will not be functional in 10,000 years. So it will be just space trash. But you can imagine a more advanced civilization, because we had only 1 century of science and technology. But if another civilization, had science and technology for thousands of years, maybe 1 million years, they could have sent probes that would survive the journey and would still be around in now, billions of years after they were made. And the question is, are they around us? Is there any evidence? Because the Director of National Intelligence submitted 3 reports to the US Congress about unidentified anomalous phenomena. And if you think about it, these reports, if you don't believe that there are any extraterrestrial objects that these reports are describing, then it's the intelligence agencies admitting that they're not doing their job. Because if it's all made by humans and they cannot figure out the nature of these objects, either they should get a pay cut or a boost in their funding so that, people should get alarmed that there are objects flying in the sky that we don't understand. Indeed, there was this Chinese spy balloon that was shut down. Maybe there are many more that we haven't realized. My point is that it's a question that should be addressed using the scientific method by collecting data, and we should figure out if humans are sending these anomalous objects that the government is unable to identify. I was actually at the Washington National Cathedral in the company of Avril Haines, the Director of National Intelligence, after she submitted the first report. And since she has a bachelor's degree from the University of Chicago in physics, we speak the same language. And I asked her, what do you make of these objects? And she said, I don't know. And then Jeff Bezos went to the stage and talked about the fact that he was inspired to create Blue Origins after watching Star Trek as a kid. And I said to Avril, I never liked science fiction because it involves fiction. I cannot enjoy it because it violates the laws of physics. The storyline doesn't make any sense. And she said, Avi, we have to work on you. So, and it was interesting that I was invited, the first scientist to be invited to this Munich security conference where heads of state and other important politicians come together every year. And when we went to have a drink on the roof of the hotel, I could see snipers with black head covers on the roof. And I realized they're not here to protect me. They're here to protect Volodymyr Zelensky, for example. And I then realized that indeed being a politician is far more controversial than being a scientist. So I'm in the right business. I'm just trying to figure out the world,
What do you make of some of these? I mean, I know you did Ryan Graves' podcast.
Right.
And David Favor, I think I'm saying his name right. And
Fravor, yeah.
Fravor, excuse me. But, you know, these underwater UAPs, just all of the UAP, UFO phenomena type stuff that we're catching on camera. What do you make of this stuff?
Well, we need better data. The data that is available is not good enough because we don't know the distances to those objects. Just to give you an example, suppose you are in a highway and you see a black car behind you. And then you look forward and you see a black car in front of you. And then you say, wow, that's amazing. This black car was moving really fast. I didn't even notice when I looked at the rear view mirror. I didn't really notice the car passing. But it could be that it's not the same car.
Time doesn't slow down, and really, you shouldn't either. We all sit around and say, oh, I'll get to that later, but some things shouldn't wait, like protecting your family's financial future. Fabric by Gerber Life is term life insurance you can get done today. It's made for busy parents like you, all online on your schedule, right from your couch. You could be covered in under 10 minutes with no health exam required. Fabric has flexible, high-quality policies that fit your family and your budget, like $1 million in coverage for less than $1 a day. If you have kids, and especially if you're young and healthy, the time to lock in low rates is now. Join the thousands of parents who trust Fabric to help protect their family. Apply today in just minutes at meetfabric.com/srclips. That's meetfabric.com/srclips. meetfabric.com/srclips. Policies issued by Western Southern Life Assurance Company, not available in certain states. Prices subject to underwriting and health questions.
And so if you have a swarm of objects that come in and out of view, you might think that they're moving really fast, but it's not the same object. So what we need is really much better data. And unfortunately, as we discussed before, the US government classifies most of the interesting data. They release data which is not as convincing. Mm-hmm. And the fundamental question is, are they hiding something of great scientific interest? I would not exclude that possibility, but waiting for them to release classified information is like waiting for Godot, the play of Samuel Beckett. You can wait forever. And that's not a good approach because we live a short life. I want to know the answer. If they do have the information, I beg them to release it because otherwise I'll waste 20 years of my life, the remaining part of my active life, looking for the answer when they already have the answer. So I really hope that they would share it because anything that lies beyond the solar system, it's not a matter of national security. From a large distance, you can't really tell that the Earth is split into nations. When you look at the Earth from the moon, mm-hmm. you don't see the border between Russia and Ukraine. And so it makes zero sense to maintain such information confidential. It's as if you were the President of the United States were to decide that indeed the sun is made of hydrogen, but we shouldn't let the public know about it. And hiding information from the public on scientific matters makes no sense because eventually it will come to light. And the way I approach it is in the scientific way, that I don't care about anything that may have national security implications. That's what the government should do. But if there is 1 in a billion objects that came from outside of this Earth, we should know about it. And with the Galileo project, we developed a new brand of observatories. We have one operating right now at Harvard University. Over the past few months, we looked at 500,000 objects. It's looking at the entire sky in the infrared, in the optical, in the radio, and in audio. And then we have machine learning software trying to figure out whether we are looking at a bird, a drone, a balloon, an airplane. So far, we haven't seen anything anomalous, but it's one location near Boston. And we are assembling a copy of that observatory in Colorado.
How were these locations chosen? They have to be
The Harvard
strategic.
location was just a test place. We wanted to be able to test the instruments that we have, calibrate them, see that they perform to our satisfaction. The Colorado one was for a change in place, but it potentially could be moved elsewhere. And then we have a third one that was just funded by the Richard King Mellon Foundation at $575,000. And we will assemble a third observatory in Pennsylvania because they paid for it to be there. In principle, we can build an observatory for $500,000 in any location. So it's just a matter of funding. And my hope is that we will have tens of them and we will record billions of objects over several decades. So we will get to the bottom of the question of whether there are objects in our sky that are not from this Earth. Okay, we will know. Whether anything happened in the distant past, like 50 years ago, will be very difficult for us to tell, because if events are very rare, that they happen once per century, once per half century, then we might not be lucky to be at the right place at the right time to see them. But what is important is that military personnel, when they report about an unidentified anomalous phenomena, they happen to be at the right place at the right time. But that is an anecdotal report. They don't sit there for a long period of time looking at the entire sky. And so what we are doing allows us to calibrate the noise from the background so that if something unusual shows up, we can say how unusual it is. And this is one branch of the Galileo project. A second branch is to search for unusual interstellar objects using the data that comes from the Rubin Observatory in a year, that will monitor the southern sky every 4 days, and we'll have the sensitivity to find objects like Umuamua.
Is this the one in Chile?
In Chile.
How was that location chosen?
That was the National Science Foundation. That's a very good location for telescopes because the visibility is great. Chile has this set of mountains where the best telescopes in the world they operate. So it was chosen for that reason.
Okay.
It's very good for astronomy. And we hope to use the data coming from that observatory to find more objects that are interstellar in origin and look as weird as Umuamua, so we can figure out whether any of them might be technological in origin. Okay? And then there is the third branch of the Galileo project that I'm most excited about, and that is looking for the materials of interstellar meteors. So, for example, the one discovered in 2014 by the US government satellites exploded about 70 miles away from the coast of Papua New Guinea in the Pacific Ocean. So once the US government confirmed, the Department of Defense confirmed the location and the velocity of this meteor, I decided to lead an expedition to search for the materials, the remains of that meteor at the bottom of the ocean. And just to explain, we're talking about the floor being at a depth of a mile across a region that is 7 miles in width.
Wow.
And that is the fireball location that was publicly disclosed by the US Space Command. And so we went there. This expedition cost $1.5 million. There were about 30 people with me on a ship that was fittingly called Silver Star. And we used a sled that had magnets on both sides and placed it on the ocean floor and dragged the sled back and forth 26 times across that region. And it's just like mowing the lawn. Except the first challenge was to keep the sled on the ocean floor because it would very often kite by the tension in the cable that connected it to the ship. The length of the cable was about 3 miles. And we would just skim the ocean floor, and eventually bring the sled to the deck of the ship and collect all the materials on the magnets. And I was the chief scientist on this expedition, and they would wake me up in the middle of the night. I didn't sleep much. I wrote 43 diary reports on this expedition and put them on medium.com, and that's where I post essays every day or two. And they were read by millions of people around the world, translated to Spanish. People were fascinated by the way science is done, which is collecting materials and analyzing them to figure out the origin of this object. There was even a person in Denmark that emailed me when I was on the ship to tell me that he had a stroke, and reading about the expedition gave him the will to live. For me, that was the most rewarding message that I got, because, just being curious and following the method of science appears to be rare. You ask yourself, why? Well, the reason is because in academia, a lot of people are driven by the wish to show off. They want to demonstrate that they are smart, so they get honors, awards. And the way to do that is not to make mistakes, not to take risks, not to be too curious, because if you are too curious, you sometimes make mistakes. Like a kid, you explore things, you harm yourself, you don't do the right thing, you make mistakes along the way. And so, even though these people started as kids, they lost the curiosity when they became adults. And if you think about it, the whole idea of tenure in academia that gives you the freedom to pursue your curiosity, to pursue things that are not popular at the time, to give you job security, is being abused by people who are using it to just empower themselves. And so common sense is not common in academia. And when I went to the expedition, a lot of scientists, I wouldn't say a lot, but a few of them were arguing that I will not find anything and that they don't believe the US government. We went there, we found materials. We found molten droplets in the site of the fireball from this meteor. And we brought the materials back. I gave them to my colleague at Harvard University, a well-renowned geochemist named Stein Jacobson. And over 9 months, he used the best instruments in the world to analyze them. And we realized that the chemical composition of 10% of the molten droplets that we brought back was different than materials from the solar system that was previously reported in the scientific literature. So we believe, material that may have come from outside the solar system. But the droplets that we discovered were less than a millimeter in size. They were the size of a grain of sand.
Wow.
But they looked very distinct from sand because they looked like metallic marbles. And when I took photographs of them on the ship and wrote some Medium reports about them, my daughter saw the images and she said, Dad, they look so beautiful because they look like metallic marbles. And she said, could you put one of them on a necklace so that I can wear it? And I said, well, these are less than a millimeter in size. They're made mostly of iron. You can't thread them. But they look beautiful. And the hope is that we can find bigger pieces. So we are now planning the next expedition, hopefully within a year. It will cost $6.5 million, much more, 4 times more than the previous one. And we will be looking for bigger pieces, perhaps even the wreckage of the core of the object that collided with Earth. And for that, we want to use a remotely operated vehicle, an ROV, that we put on the ocean floor and have a video feed so we can see the pieces that we are picking up. That's why it's more expensive. And we are now seeking the funding for this expedition, and hopefully we'll get it soon so that we can start to build the tools that we will use.
What did your colleague find from the samples?
We found a chemical composition that looked very different than the crust of the Earth, Mars, the Moon, asteroids. So it looks as if it's material that came from another star. To figure it out better, we really need bigger pieces, because what happened is these molten droplets lost some of the elements that made them in the explosion. These are called volatile elements that can evaporate and be lost during the explosion. But if we find bigger pieces, they retained all the elements that made the object. Also, we can tell what the object was like. We can tell the difference between a rock and a technological gadget. Just imagine a computer. If you were to burn it up and melt it, you would find droplets left over. So it would tell you that the composition was unusual, but it will not tell you what the original object was. However, if you find a big piece of the screen, then you would realize that it's not a rock. And so if we find a gadget at the bottom of the ocean, and it has, for example, buttons on it, the fundamental question is, should we press a button? And I asked my students, in my class, what do you think I should do? And half of them said, please don't do that. Don't press a button because it will affect all of us. And then the other half of the class said, please do, because we are really curious to know whether, maybe it's ChatGPT 100, it will do some amazing things. And then one student raised his hand and said, well, given the split vote, what would you actually do, Professor Loeb? And I said, I will take it to a laboratory and study it, examine it, before engaging with it.
No matter where you're watching Shawn Ryan Show from, if you get anything out of this, please like, comment, subscribe, and most importantly, share this everywhere you possibly can. And if you're feeling extra generous, please leave us a review on Apple and Spotify podcasts.